I'm Tim Peake, and on December the 15th, 2015, I climbed aboard the Russian-built Soyuz rocket, and I became one of about 600 people to leave the Earth. Living on the International Space Station was simply the most amazing 6 months of my life.
All right, gentlemen, looking great. Glad to see you both out there together on the tip of the world.
It was extraordinary being up amongst the stars, looking down on the Earth. It really made me appreciate our own planet. But it also gave me a connection to the worlds beyond. In this series, I'm going to take you on a voyage of discovery as I uncover the hidden secrets of our universe and share some of the amazing things I discovered in space. With a combination of incredible real footage and stunning visual effects, I'll reveal the planets in our solar system, look to the stars,
these images show the power of our sun.
Discover black holes.
If you were to fall into a black hole, you get stretched out like spaghetti.
I'll be sharing the reality of life in space.
It really is quite simple. Here's the tube you pee in.
And I'll see how space is changing life on Earth. The laptop was invented for the space shuttle missions, kicking off a portable computer revolution. I'll even come face to face with the capsule that brought me home. This spacecraft would have been wrapped in a ball of burning gas. Join me as I travel to the corners of the globe to discover what's out there and maybe even answer the biggest question of all. Could there be life beyond Earth? I'm starting my journey to discover our universe's secrets with a night of stargazing. The universe is made up of hundreds of billions of galaxies, and our Earth, the Sun, and the other planets in the solar system, they're all part of a galaxy known as the Milky Way. And I'm headed off to one of the best places on Earth to see it. Hi, Natasha. Great to see you. What an incredible place to meet.
I know, fantastic, isn't it? Should we take a wander?
Absolutely stunning. I've met up with leading British astronomer, Dr. Natasha Hurley-Walker. I'm here because the outback of Western Australia offers some of the darkest skies on the planet, giving you a front row seat of the Milky Way. What a stunning moon tonight.
Beautiful.
Venus up in the sky as well.
Yeah. Oh, the Milky Way just coming out.
Hidden within this sea of twinkling stars are the planets of our solar system. To get a closer look at some of our neighbours, Natasha has set up a telescope. Natasha, this is a big telescope to have out here.
It's just about portable.
What are we going to have a look at?
I thought we could have a look at Mars.
Let's do it.
That should be all lined up.
Wow. That is incredible. So that's the view that we're getting right now.
Yeah, that's right.
You can even see the shades of red there, different textures on the planet.
And if you look just here, you can see one of the polar ice caps.
I think that's hundreds of millions of kilometres away right now. Just so many stars out this evening, it's amazing. Are there any other planets we can see tonight?
Yeah, I thought we could take a look at one of my favourites, Saturn. And there it is.
Oh, that is beautiful.
It really is the most iconic planet in the solar system.
That's right. If you ask any kid in the world to draw a picture of a planet, this is the one they would draw.
The colours are just amazing, and the clarity as well, to think that that is over 1 billion kilometres away and we can see it as well as that.
I know, right? 5 times further than Mars.
Incredible. Looking up at our galaxy can make you feel small and insignificant, but it also gives you a connection to the stars and the planets. It gives us a sense of belonging to something so much bigger.
There are 8 officially recognised planets in our solar system, which sit within the Milky Way. These planets all travel around the Sun. The closest is the tiny scorched world of Mercury. Next come Venus, and then our home, Earth. Then the red planet of Mars, and further out, the biggest planet, Jupiter. Then Saturn with its beautiful rings. And finally, the coldest, furthest planets, Uranus and Neptune. I'm going to explore every one of the 8 planets in our solar system, discovering what makes them so different and special. I'm starting my quest with our closest neighbour. It's so close to Earth, I can see it from my rooftop. You see that bright spot in the sky up there? Well, that's Venus. And because it's so bright, you don't need any special equipment to be able to see it. So no telescope required. But if you want to check that bright light in the sky is Venus, there you go, got it. You can actually do it on your mobile phone. Venus is about 61 million kilometers from Earth. One day here is equivalent to 243 Earth days. And while the Earth's average surface temperature is a pleasant 15 degrees Celsius, Venus bakes at 475 degrees. I want to find out more about our closest neighbour. And to help me, once again, I'm going to leave the Earth.
I'm on the outskirts of York this morning, and whilst I'm not about to go into space, I am going to take to the skies. Morning, Jen.
Morning.
How are you?
Yeah, good, thanks.
Good to see you.
Yeah.
Okay. We're off. Thank you. Thanks, everyone. Bye-bye.
It's a little more sedate than I'm used to, but looking at the clouds and atmosphere of our planet with Dr. Jen Gupta will help me find out more about what it's like on Venus.
I'm used to the rockets pointing downwards.
Bit more calm than your rocket launch then.
Yours, there we go.
It's so easy to forget how spectacular our own home planet is, planet Earth. You know, looking out there, seeing the trees, the river, it's just glorious.
I know exactly how Jen feels. Being in space gave me time to reflect on the beauty of our own planet and the other planets in our solar system. I had time to ponder the big questions, like could life exist anywhere else? Could it ever have taken hold on somewhere like Venus? To get to the bottom of that one, we need to understand how life began on Earth. Life is thought to have taken hold in our oceans pretty quickly after the Earth was formed. But it was a very simple form of life, single cells, or a collection of a few cells. And it took almost 4 billion years to evolve into the plants, animals, and humans that we see today.
And of course, all of this only possible because our planet formed 4 billion years ago and was exactly the right distance away from the sun.
Yeah, that's right. So we're in what's called the habitable zone. It's not too hot, it's not too cold. The temperature is just right for water, that essential requirement for all life that we found here on Earth to exist as a liquid. But Earth isn't the only planet that would have formed with water, and there's no reason to think that the same wouldn't have happened on Venus, forming, rivers and oceans across the surface.
So if Venus had flowing water and oceans, there's every possibility that life could have evolved on Venus too.
Well, maybe, but I've got a picture to show you. So this is the first colour picture of the surface of Venus, taken in 1982.
Wow, look at that. You can see the spacecraft in the bottom of the picture and Venus beyond.
I mean, that's really quite shocking, isn't it? I mean, it certainly looks very barren and hostile and all sun-baked and cracked, devoid of any life by the looks of it. I mean, what happened to all the water?
I'm going to put this down before it goes over the side. I think this is one of the things that really excites me about science, that we still don't quite know. One of the best theories that we have, though, we have to look towards the sun. As stars get older, they get hotter and brighter. So in the past, the sun was dimmer and the surface temperature on Venus was then lower, and you could have this liquid water.
So as the sun got hotter, it just boiled away the oceans off into steam, and then that steam in the atmosphere made the planet too hot.
Yeah, all of that water, turned into clouds surrounding the entire planet on Venus. It's a bit like wrapping it up in a nice cozy blanket. So Venus just got hotter and hotter. It basically baked. It's got a surface temperature of up to 480 degrees Celsius. That's hot enough to melt lead, which makes Venus actually the hottest planet in our solar system today.
And of course, Venus is a record breaker in another way, because all that cloud in the atmosphere reflects sunlight back into space. So we see Venus at night as the brightest object in the sky other than the moon.
Venus could be a lesson to us on Earth. Burning more and more fossil fuels will lead to a hotter world. Our planet could easily become barren, just like Venus. But Venus isn't the only planet that had Earth-like conditions in the past. Next, I'll be looking at Mars. Could it once have had water? To find out, I'll be traveling thousands of miles to a place on Earth with an almost identical landscape. For over 20 years, people have lived and worked on the International Space Station. And for 6 months, I orbited the Earth at nearly 28,000 kilometers per hour. I saw 16 sunrises every day. And it gave me time to look down and wonder about how different our world is to every other planet in the solar system.
Earth is teeming with life. It's estimated there are around 9 million different species on our planet. Every area of our globe is populated by insects, birds, plants and animals, including us humans.
And over the last 500 million years or so, that life has changed our planet beyond all recognition. But there's a place that's pretty much stayed the same for millions of years. A place that looks like another world.
The Grand Canyon. It's one of the most stunning sights on Earth. Formed over 6 million years by the Colorado River, cutting through the terrain and revealing our rocky planet below.
Giving us a mirror image of the next planet further out in our solar system. 225 million kilometers from Earth is the planet of Mars. Sheets of frozen carbon dioxide cover the poles. And nestled in between the red sand is a tear that goes almost a fifth of the way round the middle of the planet. This is the daddy of all canyons. Valles Marineris is the largest land-based canyon in the solar system. 3,000 kilometers long, it would easily swallow up 4 Grand Canyons. But their color is the same.
And that redness is caused by the iron content in the soil. And we all know what happens to iron if you leave it out in the rain for long enough. It rusts.
Leaving a deep red color.
Like Venus, Mars once had plenty of water, covering as much as 1/3 of the surface. And NASA scientists have a mantra. If you want to find signs of life, follow the water.
Although we've never walked on Mars, we have sent almost 50 uncrewed missions there, revealing evidence of a wet past. Dried up riverbeds, eroded valleys, and stones that have been smoothed into pebbles by ancient water. There have been many theories of where water may be hidden on present-day Mars, and some scientists believe that below the frozen carbon dioxide poles is an ocean of water. But for over 50 years, we've searched the red planet's surface and not found a single drop. But we have discovered something incredible. Carbon-based chemicals, the type that every living thing on Earth is made from. But that doesn't mean we've completed our search and found life.
I like to think of it a bit like when you're making dinner and you've got all the cooking ingredients stretched out on the work surface in front of you. In this case, that's the chemicals that we find in the plants and animals on Earth. But it's not a meal until you've mixed that all together and cooked it up.
The recipe for life to evolve on Earth required time, lots of it, billions of years, along with that other essential ingredient, water. And incredibly, we've discovered water hidden out in space in the most unlikely of places.
1 and 0 and liftoff of Messenger on NASA's mission to Mercury, a planetary enigma in our inner solar system.
In 2004, NASA sent a spacecraft called Messenger on an audacious 77 million kilometer voyage to the closest planet to the Sun. Mercury is the smallest planet in our solar system, just slightly larger than our moon. And it's the fastest, traveling through space at nearly 47 kilometers every second, compared to Earth's 30 kilometers.
Mercury is a planet of extremes. The surface facing the Sun is a scorching 430 degrees Celsius, whilst the temperature on the other side plummets to a freezing -170.
And hidden in the shadows of Mercury's many craters, out of the heat of the Sun, hides something incredible: frozen water. And in that ice, we found evidence of simple carbon molecules, the building blocks for life.
There's clearly something astonishing going on with Mercury. The ingredients for life are there, but could life really have started in the sub-zero, icy conditions on the planet? To find out, I've come to Cambridge, home to the British Antarctic Survey.
Temperature's pretty important for life to survive. If things get too hot or too cold, they tend to die.
Maddie Lewis is an expert in how life can survive under the most extreme conditions.
Mercury can get to a crazy -170 degrees Celsius, but surely you wouldn't expect life to survive there.
Traditionally, no, but that's what this kind of research is meant to be doing. Looking at places on Earth and seeing how cold can it get and we still find life living.
Right, so that's why we're getting togged up in cold weather gear.
Yeah.
And it's a nice spring day out there.
Exactly.
Welcome to our ice lab.
We keep it at minus 25 degrees so we can store our ice cores.
Right.
They have been drilled out of the surface of Antarctic ice sheets, and in here we can process them, chop them up, ready for our experiments without them melting all over us.
Of course, we can't bring the ice back from Mercury, but I guess by analysing these samples from Antarctica, we can at least discover if life can exist in freezing temperatures.
Exactly. This is the closest proxy we have to ice found in the rest of the solar system.
When we talk about life in ice, we're not talking about big animals, or even small ones like ants. What Maddie and her team look for is tiny bacteria and single-celled organisms. Back in the warm laboratory, it's time to see if there is any sign of life in the melted ice.
Ah, okay, so... Here, Tim, look at this.
Oh, wow. I must admit, I didn't expect to see so much stuff. None of it's moving, though, so I assume this is all dead.
It could be dead, or it could be cells in stasis waiting for the right conditions to wake up again.
So if we found life in deep hibernation in the ice in Antarctica, is it possible that we might find life in deep hibernation in the ice in Mercury?
When we think about the evolution of life without liquid water, it's probably not possible.
And to our knowledge, of course, Mercury hasn't had any liquid water. We think the ice that arrived on the planet came from an asteroid impact.
Exactly. That would pretty much count out the evolution of life.
But the universe is a big place. And further out from the sun are even stranger, mysterious worlds. These ginormous outer planets, Jupiter, Saturn, Uranus, and Neptune, are beyond our wildest dreams. The inner planets of our solar system, Mercury, Venus, Earth, and Mars, are known as the rocky planets. But 500 million kilometers or so past Mars, everything changes. These outer planets really are totally different worlds. Jupiter is the 5th planet from the Sun. It would swallow up 1,300 Earths. It's simply ginormous, more than twice as big as all the other planets combined. Made mostly of gases, with no surface to walk on. It really is a different class of planet, known as a gas giant. To discover more about this incredibly strange, wonderful, and crazy planet, I've come to London, to the Royal Observatory at Greenwich. I'm here to meet someone who knows a thing or two about Jupiter. Dr. Dominic Walliman.
Welcome to planet Jupiter.
Wow, it's incredible. So colourful. It's like a big Christmas bauble hanging in space.
It's like a marbled, gassy world made of the same stuff as our sun.
So if it's made of the same stuff as our sun, how come it's not on fire?
Yeah, well, it's 10 times smaller than the sun, so there's not enough stuff there to ignite and burn like a star.
And what's with the coloured bands? I mean, it's beautiful.
Yeah, so the light bands, that's hot gases rising up from beneath the surface, just like hot air rises. And then the darker belts, that's cooler gases sinking down.
So it's an active planet then, it's not quiet or sedate?
Far from it. In fact, that red spot, that's a giant hurricane that astronomers have been watching for over 300 years.
From the space station, I used to see huge storms forming over the Atlantic Ocean and watch them sweep over the US. It's a powerful sight to look down high above the Earth and watch our weather patterns. All that wind and turbulence caused by the heat from the sun warming our atmosphere.
But the thing is, Jupiter's 5 times further out than the Earth, and so the sun's rays don't have enough energy to generate these storms. What we think's going on is the heat is coming from deep within the planet, heat that was trapped there when the planet formed, and now Jupiter's cooling down. So just like, say, when you get a pie out of the oven and it loses its heat to the air around it, the same kind of thing's happening on Jupiter, where the heat from the inside is driving these storms.
And that's what causes the Great Red Spot.
Yeah, and it's by far the largest storm in our solar system. It's so big that it could engulf the entire Earth.
Jupiter really is a stunning and intriguing place. And we're only just beginning to discover more about these distant worlds that are so far from our sun. But I think the next planet further out is the most beautiful of them all. Nearly 1.5 billion kilometers from the sun, that's over 9 times further away than the Earth is, lies Saturn. Circled by 145 moons, it's our second largest planet. Because of its majestic rings, it's known as the solar system's jewel in the crown. But those rings could have formed as recently as 100 million years ago, about the same time as dinosaurs walked the Earth. And we think they were made by one of the universe's fundamental forces: gravity.
Arnside in Cumbria isn't the first place that most people would head to find out how the rings of Saturn were made. But this vast expanse of sand and water in the northwest of England is the perfect place to see how gravity can change a planet.
I've come to meet Dr. Carly Howitt to get to the bottom of how the rings of Saturn came to be.
First things first, what exactly is gravity? Because it's one of those things that we've all heard of it, but it's difficult to explain.
We're all used to the idea of gravity. Most people know what will happen to this rock if I let go of it. The small rock falls towards the very heavy Earth, and that's the effect of gravity.
So it's a bit like magnetism. We can't see it, but we know it's there. We can see it working. And of course, it's not just here on Earth where gravity has an effect. We see the same force play out across the solar system, affecting all the planets and their moons as they interact with each other.
And that's why we're in this beautiful bay. Right now you can see the sand flats. But in a few hours, that's going to dramatically change. And that's down to our moon.
The moon, even if you can't see it during the day, is constantly exerting a gravitational pull on the Earth. The most obvious way we can see this is when the tide comes in, which is caused by the gravitational force of the moon pulling the water towards it. And here in Arnside, the tide comes in fast and deep, covering the sandbanks in a matter of minutes, filling the whole bay with water.
This is really impressive to see the tide coming in so quickly, but what's the tide got to do with how the rings formed around Saturn?
Well, that effect of gravity is present everywhere in our solar system, and in some places disrupting worlds. And Saturn's rings formed because gravity pulled one of its moons too close to the planet.
This moon was traveling around Saturn at an incredible speed. But once it got too close to the planet, it was doomed.
Saturn's gravity is huge, and so it's pulling on this moon while it's orbiting the planet.
So it's being pulled in 2 different directions then?
And there's only ever going to be one outcome.
The moon is stretched like a piece of elastic until rock by rock, it breaks apart.
So this moon didn't crash into Saturn, but it was ripped apart by its gravitational pull and then broke into trillions of pieces that now swirl around the planet, which I get. But how come there are so many separate rings to Saturn?
Right, so let's pretend this big rock is Saturn. Around the outside of it is all the pieces that were left over from that moon that was torn apart. But Saturn has other moons. And each of those moons, as it moves around Saturn, is going to sweep out all of the debris that's in front of it. And Saturn has multiple moons, which means this is going to happen in multiple places. So another moon will clear another path. And that's why it looks like Saturn has multiple rings.
What a lovely story, and a true secret of how part of our universe was formed. But this planet holds yet another secret.
3, 2, 1, and liftoff of the Cassini spacecraft on a billion-mile trek to Saturn.
In 2005, when the Cassini spacecraft pointed its cameras towards Enceladus, one of Saturn's 145 moons, we discovered something extraordinary. So far from the warming rays of the sun, we expected to see a frozen ball of ice. But we found an active moon that hides an ocean of liquid, salty water beneath its crust. And plumes of that water, containing simple organic chemicals, exploding into space. So all the ingredients for life can be found nearly 1.5 billion kilometers from the sun, which raises a very interesting question. Even in the furthest, coldest places, in the depths of space, could life still be possible? To get to the last two planets in the solar system, Uranus and Neptune, really was pushing our limits of space travel. The journey to Uranus, the 7th planet from the Sun, is nearly 3 billion kilometers. That's 19 times the distance that Earth is from the warming rays of the Sun. In 1977, NASA launched Voyager 2, its deep space probe. It took 9.5 years, flying at an incredible 15 kilometers every second, for Voyager to reach Uranus.
The trouble with travelling this distance is that Voyager 2 just didn't have enough fuel to slow down and to settle into orbit around the planet. So after such a long journey, the spacecraft spent just hours giving us a fly past of Uranus. And what we found was probably the least thrilling of all the planets.
Voyager 2 is the only spacecraft we've sent to Uranus, and we found a bland, pale planet with hardly a cloud. At a freezing minus 224 degrees Celsius, Voyager recorded the lowest temperature of a planet in the solar system.
Voyager 2 carried on its lonely journey for another 1.5 billion kilometers to Neptune, the last planet in the solar system. And after the disappointment of Uranus, it's fair to say that NASA were far from optimistic about finding an interesting world. But they were wrong.
One day on Neptune lasts for about 16 hours. But it takes so long to travel once around the Sun that its year is equivalent to 165 Earth years. No human would ever see their first birthday. Roughly 4 times wider than Earth, if Earth were the size of a grape, then Neptune would be the size of an apple. And you can't miss the fact that Neptune is a deep, piercing blue.
come to Tenerife, an island in the Atlantic Ocean off the northwest coast of Africa. Here you'll find some of the clearest and bluest waters that you'll ever see. It's absolutely stunning, but it's also the perfect place to discover why Neptune is so blue. Hey, Tammy.
Hello.
Good to see you.
Welcome to the VIP, as we usually say.
This is fantastic. You've got one of the best jobs in the world.
I don't complain.
It took 12 years for Voyager 2 to reach Neptune, but it was worth the wait.
The spacecraft beamed images back of Neptune, this beautiful blue marble hanging in the darkness of space. And for decades, that colour was a puzzle. Neptune became known as the second blue planet after Earth.
You get a totally different perspective of our blue planet when you look down at it from space. Over 70% of our globe is covered in water, giving you this beautiful blue world, a water world. And one of the best pictures I took when I was in space was of Tenerife, sitting in a pool of blue.
We know why water looks blue. The white light from our sun that bathes our planet is actually made from a spectrum of different colours, ranging from red to yellow to green to blue and violet, just like a rainbow. And all of this water around me is absorbing that red end of the spectrum. It's sucking it in, and it's reflecting the blue light that we see with our eyes. But that leaves us with a big question. There are no oceans of flowing water on Neptune. So why is it so blue? Voyager 2 gave us the answer. It discovered that Neptune's colour comes from its cloud tops. The clouds contain methane, more commonly known to us as natural gas, that heats our homes here on Earth. And just like water, methane soaks up the red light from the sun's rays, reflecting back the blue light, making Neptune look a beautiful azure blue.
Voyager 2 gave us a quick glimpse of the intriguing worlds of Uranus and Neptune. It's now left our solar system, travelling unimaginably far into our galaxy, the Milky Way. The spacecraft still sends signals back to Earth, but it's now too far away to send images. But there are ways that we are starting to explore past our planets and our solar system.
I want to see what lies far out in the depths of the universe. So I've travelled almost 2.5 kilometres up to the summit of Mount Teide, an active volcano in the centre of Tenerife.
Up here above the clouds, away from the light of the city, is Teide Observatory. You might have been to Tenerife and not even realised it was here. But tucked away on the top of this volcano, far from the holidaymakers, is a telescope being used to do some incredible research.
And welcome to Teide Observatory, where we search for planets beyond our solar system.
How cool is that? Great to meet you, Hannah.
Dr. Hannah Wakeford is a planet hunting expert.
So Hannah, it's one thing to use a telescope to look up and try and find other stars in the universe, but you're using a telescope to try and find other planets in the galaxy.
Yeah, and imagine how small those tiny little planets are around those stars. And the stars are already just pinpricks of light on our sky.
So you must need a really powerful telescope to do that.
A powerful telescope and some very powerful and clever techniques that we've come up with.
Hannah's problem is that the planets she is hunting for are so far away that even with our most advanced telescopes, they're too small to see.
So this is a state-of-the-art telescope. What it's looking for is the small change in the amount of light when a planet passes in front of its star from our point of view.
Oh, wow. So it's a bit like if you had a torch there and you passed your finger in front of it, you'll see it dim slightly.
Yeah, a bit like that, but imagine that it is a fly in front of a street lamp a kilometre away.
Wow. So it's super sensitive.
Yeah. So what we're seeing here is actual data from the telescope, and we're looking at this big red star through time, and then the planet passes in front of the star and we see this dip in the light that shows us, that tells us there is a planet around that star.
I find it absolutely mind-boggling that just by noticing a dip in brightness from a star, we know that there is a planet billions and billions of kilometres outside of our solar system. I mean, effectively, you found a needle in a haystack here.
Yeah, we have to look at hundreds of thousands of stars to be able to find events like this and discover planets outside of our solar system. And we have found over 5,000 planets.
Wow. And you think there's hundreds of billions of stars in our Milky Way galaxy alone, so there must be billions and billions of planets out there too.
Yeah, we know that there are more planets than there are stars, and there are more stars than, in fact, grains of sand on the Earth. So the numbers are truly astronomical.
And with so many planets out there in the universe, the potential for life elsewhere, it must be vast.
Yeah, it's absolutely huge, and we're learning things every single day.
I find it incredible that there could be life on planets that we know exist out there in the vastness of space, just waiting to be explored. At the moment, they're too far away for us to travel to, but finding them is the first step on the road to answering one of the biggest questions we can possibly ask. Is there life beyond Earth? And it's places like here, at the top of the world, where our search for life beyond our solar system is just beginning.